This is the third assignment for quiz 5 in Algebra 2 in the second try. So you should be fairly familiar with everything by this time. Just make sure you're matching up the steps on this recipe with the steps in these problems, and you should have very little problem. So we want to factor and cancel on step 1, and it's likely when you factor, there'll be some canceling. So there's the factoring. And that's what we have. One note here, when you don't have anything left in the numerator after you cancel, that's a 1. And so factors, if the x's drop out of the numerator, you don't have an x-intercept. So that's a note. I'm going to go down and put that right away. So make sure that you note that. So number 2, x plus 1 equals 0, x equals -1. Number 3, so here's a case where you'll notice back on this original, we are looking again at the highest powered term. So let me highlight those. Right here they are. And as you look at those, if the powers are the same, then we're going to do 1 divided by 1, the divide the coefficients. But that's not the case. The power is greater in the denominator. So automatically, the answer is y equals 0, the x-axis. That's automatic. You just go there. If the x squared was in the numerator and the x to the first was in the denominator, then there would be none. So that tells me there's no oblique asymptotes. Again, we will deal with those later. Point discontinuities. We did cancel. So these exist when you cancel a factor, okay? And then you're going to put it into what's left over. This is what y is. So y would equal 1 over -3. So -4, and you need to write it as a coordinate. Find the y-intercept. Let x be 0. Over 0 plus 1. You can use the original if you want, 4 over 4. Either way, that doesn't matter on that one. Okay, so we're ready to go. So -1, vertical asymptote. Y equals 0, so that's the x-axis. Point discontinuities, -4, -1/3, so right about there. And then y-intercept is 1, and there's not an x-intercept. So here's what this graph is going to look like. Again, if you need to look at this on your graph, or do it. But one thing is for sure, it has to be getting close to, the x-axis, because that's a horizontal asymptote, and it has to be getting close to -1 vertically. Has to. Okay, and then the domain and range. Remember, you're taking out the vertical asymptote and the x value that's part of the point discontinuity. So that guy right there is your point discontinuity. These would be the same. Okay, so number 3. Moving along. Oh, we have our first oblique asymptote. Get ready. I don't think I give you one on the quiz because it's not real important, but there is one here, just so you know that there is one. So when you factor, and note that there's no canceling, so there's not a point discontinuity. So we're still good. So x equals -2. Horizontal asymptotes, notice that the power is higher in the numerator by 1. So you need to read this when you get there on the oblique. Occurs when the highest power in the numerator exceeds the highest power in the denominator one, and the denominator still has an algebraic factor. Use long division. Oh boy, we got to do some long division. Okay, so no point discontinuities exist. Why? Because there was no canceling. Find the y-intercept. So we are going to get 0 over 2, which is 0, which automatically, I guess, yeah, okay, so it's 0. It's also an x-intercept, but there's one more x-intercept. Okay, so you need to take each of those factors equal to 0. So we also need to do x plus 4. So -4 and 0. I would definitely confirm this on your calculator's table when you're done, as you're going through this. So find the oblique asymptote. There is one because we have, again, the higher power in the numerator by 1. So what we have to do is some long division. Oh boy. And we're going to discard the remainder. So how does long division work? Well, we look at x and x squared and we figure out how many times does x go into x squared. Well, that'll be x times. Then off on the side, we do our product. So x squared plus 2x. Don't forget to do this off on the side. Draw the line, change the sign everywhere, and then add down. So x into 2x will go plus 2. And then off on the side here, we need to do this product. So 2x plus 4. And then we draw the line and change the sign, and we have a remainder of -4. All right, so that's our oblique asymptote. How's that going to work? All right, let's go back to the top here. We've got -2 as a vertical asymptote, and it is not considered to be a discontinuity. So we don't take it out of the domain and range. So x plus 2, we graph that line. And here it is. And again, it's not part of the graph. Oh boy. And so -4 is the x-intercept. And then 0 is the x and y-intercept. So what does this look like? There it is. Funny looking thing. Again, I don't know if I put this on the quiz or not. But just to know that they're there. So we're going to take out the vertical asymptote only. You do not take out the oblique. Okay, you don't worry about that. And that's it. So there's no horizontal to take out at all. Okay, number 5. Okay, so do some factoring here. And canceling. Okay, and so we get x. Now note here that a lot of people might say, yes, there's a oblique asymptote because the power is 1 higher. That's not the case because you have to have an algebraic factor left after canceling, and it does not have that. Okay, so there's a 1 in the denominator. Okay, so no oblique asymptote here. They're much more rare. So you're looking really at x over 1 if you want to look at it that way. They're much more rare than not. I meant to say an oblique asymptote. So no vertical asymptotes. No horizontal asymptotes. because the power's higher in the numerator, so that means none there. There is a point discontinuity. So you have to follow these directions to a T. If you don't, so like a number 4, you want the ditty on point discontinuities, read it. Okay, so on and so forth. Read up. It matches the list perfectly. Okay, so let x be 0, and you're going to get y equals 0. Which also means that so they're both, when one happens, the other is, because it's the origin. Okay, and that's basically all we need. So we don't have any of these asymptotes. What is this going to look like? This is going to look like a line. And sometimes this happens. It's going to be this graph with a hole at -5, -5. 2, 3, 4, 5. And that's it. So how would you know? I mean, again, you can look at your graphing calculator. There it is. Never mind that little mistake there. That's what it looks like. Okay, so x is an element of the reals, and we want to take out, so just the point discontinuity on this one we take out. Okay, so again, that's always part of what we need to take away. And that is the third assignment for quiz 5, the second try of Algebra 2.